Okay, class, today's lesson is on the unit circle. Today's objectives: first of all, evaluate trig ratios for angles that fall on the x or y axis. Understand that the radius of a circle does not matter when evaluating trig ratios. And find a point on the unit circle at a particular angle. First of all, I'd like for you to recall that the ratios in 30, 60, 90 triangles are all the same regardless of the side. My favorite 30, 60, 90 triangle is 1 across from the 30-degree angle, 2 on the hypotenuse, and radical 3. So often you'll hear me say 1, 2, radical 3. But a triangle could be smaller and maintain the same ratios. For example, if we divide all the sides by 2, just a random choice, we'd get 1 over 2. 2 over 2 would be 1, and radical 3 over 2. So these have the same ratios. Or I could make the short leg 4 doubles to 8, multiplying by radical 3. So I just want you to remember that the ratios are constant. And notice if we look at the small triangle, that 1 is multiplied by 4, the 2 is multiplied by 4, the radical 3 is also multiplied by 4. So as long as you do the same thing, the ratios are consistent. Now, let's meet the unit circle. That simply means a circle with radius 1. What I normally do is go 1 in each direction. So to the point 1, 0, over 1, up nothing, and put a point. Over 0, up 1, and put a point. Back 1, up nothing, put a point. Over nothing, down 1. And so through these 4 points, I just draw my best circle, and boom, that's our unit circle. And although I didn't show these, the radius here would still be 1. The radius in all directions is still 1. Our friend, the unit circle. Later in this lesson, we'll see what's so nice about the unit circle. So now, let's forget about the unit circle for a moment and evaluate the sine of 270 degrees. So let's recall 270 degrees is here. So before we would go to our angle and make a triangle. But now we can't really make a triangle. So what we're going to do is just pick a point and use our knowledge of x, y's, and r. Let's recall the sine of any angle is y over r. Hopefully you memorize that. So let's draw a circle so we can have a r. We need a radius. So let's say I make the radius 1. Why not? I'll say radius is 1. So what would be the coordinate of this x and y? Over 0, down 1. So now I have an x, a y, and an r. And so in that case, I would get the y coordinate is -1 and r is 1. Therefore, the sine of 270 is -1. Final answer. Very easy. But I would like to show you that it doesn't matter what I make the radius. I could have made the radius, let's see, what about radius 16? So 16 in all directions. So what would be the point at 270 degrees? Over 0, down 16. So now y over r would be -16. That's my y coordinate. and r is 16. And guess what? I still get -1. Ta-da! So it really doesn't matter. But what we have to figure out is why use the unit circle. Well, the first thing we notice is that reducing is a lot easier. But hold that thought, and hopefully I'll make it a little more obvious on this example. So let's evaluate the cosine of 150 degrees. Starting from here, of course, measuring counterclockwise. Let's go back. That line got a little funny. 150 would be around there. So my reference angle, it would be 30. And so I'm going to make a triangle and use the XYR method. Let's recall that cosine of 150, x over r, let's get our x and our r. Well, 30-degree angle, opposite is 1, hypotenuse is 2, long leg is radical 3. So this point, if we go back, radical 3, that's negative, and up 1, that's positive. So that's my x, that's my y, and 2 is my r. So now let's see what we have. Negative radical 3 for x, and r is 2, thus negative radical 3 over 2. That's one way to do it. But let's say when we found 150, we decided to make the radius of this circle 1. Still the reference of 30. And normally we would say 1, 2, radical 3. But if we want the radius to be 1, we could divide all the sides by 2, and that would make the radius 1. So if we divide everything by 2 to force the radius to be 1, keeping those constant ratios, now this point is back negative and up, which would be positive. So now that's my x, that's my y, and my radius is 1. Thus, this is a unit circle. Let's see what the cosine of 150 is now. It better be the same thing. So x on top, r on the bottom. X is negative radical 3 over 2. And r, is 1. So anytime you divide something by 1, you just get what you started with. So we can see it's the same answer. And the true beauty in the unit circle is if you have the sine of an angle, any angle, it's normally y over r. And the cosine is x over r. So what happens when r is 1? Sine is just y, and x over r is just x. So the cosine is x. Now, I don't know if you really caught the beauty in that. Let's see if you caught that. Sine is y, cosine is x. So any point on the unit circle, every point, x, y, what we see now is that this is really cosine of that angle, and this is the sine of that angle. I don't think you heard me. At any theta, at any angle, x is the cosine and y is the sine. This is true because we're in the unit circle and r becomes 1. Okay, let's talk a little bit more about the unit circle. You can practice that on your homework. What is the point on the unit circle at 315 degrees? So let's estimate 315. That would be in the fourth quadrant. 315 leaves me a 45-degree reference angle. So now what we have is a 45, 45, 90 triangle. My favorite 45, 45, 90 is 1, 1, radical 2. But I asked for the unit circle, which means I want the radius to be 1. So currently the radius is radical 2. So in order to force it to be 1, I'm going to divide everything by radical 2. So now this point right here becomes 1 over radical 2 because that's going positive, and down, that's negative. So what we see, oh, don't forget to rationalize. So now this is radical 2 over 2, negative radical 2 over 2. Okay, so we've answered the question. What is the point on the unit circle at 315 degrees? The radius is 1, and this is the coordinate. We went over, we went down, but why is this so beautiful? I don't know if you really see it. Why? Okay. This is the cosine of 315 degrees. This is the sine of 315 degrees. Beautiful, beautiful, beautiful. And of course, we still know our other ratios. We know that tangent is still y over x. So we could simply divide those and we'd quickly see the answer is -1. So just beautiful. Once we get in the unit circle, we boil down everything to the x coordinate being the cosine at that angle and the y coordinate being the sine. All right.